So let's start solving equations by finding the missing number. Okay, so in this example here we have 6 times, and we're using a symbol of a square, minus 6 is equal to 30. So this is an equation, and we know it's an equation because we have something on the left equal to something on the right. And when we find the value of this symbol here, then we'll have solved the equation. Okay. So the first thing to do really is to see that we've 6 times this symbol here. So we really want to get rid of this minus 6 and bring it over the bridge, and it turns into plus 6. So we're looking towards isolating this symbol here, getting it on its own on the left hand side in this case, in this equation. So 6 times this symbol is now equal to 30 plus 6 is 36. So this symbol must be equal to 36 divided by this 6 here, the coefficient or the number that's beside the symbol. And therefore 36 divided by 6 means that the symbol must be equal to 6. And we said the equation is solved. We can put this value of 6 where we see the symbol here, and we can say 6 times 6 is 36 minus 6. That actually is equal to 30, so we know we're on the right track. And moving on from there, in this chapter we met these balance type problems or equations where we had 3 of a certain symbol on one side of a balance, and we know it's balanced because this is even. And the 3 symbols on one side was equal to 2 symbols on the other. And we're told that we need to find the value of each of these if this symbol is equal to 6. So we write an equation, a balanced equation, and we write what we see on the left, 3 circles, is equal to what we see on the right, because it's balanced, 2 symbols, two squares, sorry. And we've given the value for the circle as equal to 6, so that's 3 times 6 on the left, just substituting 6 in for the value there, is still all equal to 2 times the square. 3 sixes are 18. That's still all equal to 2 times the square. And notice how I keep my equal signs all in a line directly underneath each other. So if 18 is equal to 2 times whatever the value of the square is, then 18 divided by this number, that's the coefficient or beside or the number of these squares, 18 divided by that 2 must be equal to the value of the square, and we find that the value of each square is equal to 9. And that makes sense because 2 9s here is 18 and 3 6s here is 18, and it's balanced. And the final balance equation here, we have 3 circles and 1 triangle is equal to the sum of 3 triangles. And we're looking to find the value of the circle if each triangle is worth 6. So if we write what we see on the left side, we see 3 triangles, 3 times the circles, plus 1 triangle here is equal to, on this side, 3 times the triangle. What's on the left, we write here. What's on the right, we write there. So we see that we can now, we're doing algebra for some time now, so we remove this multiplication symbol, and we know that 3 times 3 multiplied by a symbol is the same as in algebra writing 3 symbol. Okay, so we're not using the multiplication sign anymore. So 3 circles plus a triangle is equal to 3 triangles, and you can see we've removed, just taken away the multiplication sign from there, just for simplicity. So 3 circles, we isolate those because that's what we're looking to find, so we keep them on their own, which means we have to move this over to this side, and its sign changes from positive to negative. So 3 circles is equal to 2 triangles. 3 circles is equal to 12 because each triangle is worth 6. So each of these is worth 6, so 2 6s are 12. And if 3 circles is equal to 12, then 1 circle must be equal to 12 divided by this 3. Okay? So each circle's value is 4. And again we can check, we see that the triangles are each worth 6, so that's 18 on that side, and we're saying that each of these is worth 4, so that would give us 12 plus the 6, and that would be to 18 on this side, and it would be balanced. The equation is balanced. Let's look at solving equations now. 5 times x is equal to 35, so x is equal to 35 divided by this 5. X is equal to 7. Straightforward enough, that one. Second example, 4x plus 2 is equal to 14. Isolate your x term, keep it on its own on one side, and move the other terms over, making sure to change their sign in the process. So by moving the 2 over the bridge, its sign changes to -2. Note my equal signs are all in a row underneath each other, nice and clean looking. So 4x is equal to 14 minus 2, which is 12. X is equal to 12 divided by this 4. X is equal to 3. In this example here, we have a rectangle, okay, and it's divided into 3 parts, x, x, and x on the upper side, and that side is the same length as the lower side, which is given as 18. So to write an equation for what's happening with these dimensions, we would say that on this end, 3x is equal to the length this side, 18. So x must be equal to this 18 divided by this 3. X is equal to 6. We look at a fourth example. We have x plus 12 plus x plus 12 plus x must all be equal to 28. So gather our like terms. So we have x plus 12 is equal to 28. That's the same as 2x plus 12 is equal to 28, which we now isolate our x term, keep it on its own on one side, which means we have to move the plus 12 over the bridge. It becomes -12. So 2x is equal to 16. X is equal to that 16 divided by that 2, which is we call the coefficient of x. X is equal to 8. Now let's look at equations which contain letters on both sides. Now it's the same letter, in this case it's x. Okay, so let's say we have an equation which starts off looking like 6x minus 2 is equal to 4x minus 10. We're looking to solve the equation, we're looking to find that value of x, which when we put it in here and in here, gives us the same answer, both sides of the equation. Both sides, one side equates to the other. So what we do here always is we gather the like terms. So we have 6x on this side, we bring over the plus 4x, becomes minus 4x. We keep our 10 on the right hand side and we bring over our minus 2, becomes plus 2. So we simply gathered the x's on the left, put the numbers over on the right, and now that we have 6x minus 4x, that's 2x. That's equal to 10 plus 2, which is 12. X is equal to 12 over 2. X is equal to 6. Again, notice the equal signs all in a row underneath, so you can clearly see what's going on left and right of the equation. Now look at this example, similar, but we're going to do it in 2 different ways just to show you there's other ways of solving equations. We have 3x plus 1 equals 5x minus 3. Now it doesn't matter which side we gather the x terms, and we agreed in class to look at the equation, and if we noted that we had one x term 5x bigger than the other x term 3x, then we would gather the x's to the bigger x term side. This will save us working with a negative value of x, which we can fix, but it saves us working with that at the very outset. Okay, so we'll gather our x's to the right. So we've this 5x, bring over the plus 3x becomes minus 3x. We've this 1, which we write down, and we bring over our minus 13, which becomes plus 13. So 1 plus 13 is 14. 5x minus 3x is 2x. 14 divided by, so if 14 is equal to 2x, this x must be equal to the 14 divided by the coefficient of the x, which is 2. So that implies that x is equal to 14 over 2, x must be equal to 7. It does not matter that the x is on the right side of our solution here, not at all, it can be left or right. It just saved us messing about with negative numbers. But with the same problem, 3x plus 1 equals 5x minus 13. Let's work with, let's not gather our x's on the right hand side to save the problem of working with a negative term. Let's meet with face up to the negative term and see that it's not a problem to find the solution. So if we keep our x terms on the left, we've 3x minus 5x, because we bring the plus 5x over, it becomes minus 5x. We've minus 13, which we write here, minus 13, and we bring over our plus 1, and it becomes minus 1. Okay? So 3x minus 5x is minus 2x, minus 13 minus 14 is minus 1. So x is equal to this minus 14 divided by the coefficient of the x, which in this case is minus 2. And if you recall, when you're multiplying or dividing integers, like signs, i.e. a minus and a minus, actually give us the plus. So minus 14 divided by minus 2, the like signs gives us plus. 14 divided by 2 is 7, x is equal to 7. Same answer as we got in the previous, in the same problem which we worked out in a different way previously. Okay, a couple of more problems here. We've 3x plus 9, this length here is all equal to 4x plus 7 this side. Okay, so 3x plus 9 equals 4x plus 7. So our x term is larger on this side, 4 is bigger than 3. So we'll keep the numbers this side. 9 minus 7 is equal to this 4x minus this 3x. So 9 minus 7 is 2, 4x minus 3x is x. That's x is equal to 2. That's the solution. Okay? Of course, we can check that. We can say 3 times x is 6 plus 9 is 15 along the top, and 4 times 2 is 8 plus 7 is 15 along the bottom. One length equates to the other. That's as it should be. Another type of problem, if the sum of 3 angles in a triangle is 180 degrees, which it always is, find the value of x, which appears in the 3 angles here. So how do we do this? Well, we simply equate the sum of the 3 angles to 180. So we have this one, x minus 10 plus x plus 40, which is that one, plus x is equal to 180. Gather your x terms, x plus x minus the 10 plus the 40 is equal to 180. X plus x is 3x. Isolate it, keep to one side, which means we have to ship these numbers over here. And so that must mean that 3x is equal to 150. X is equal to this 150 divided by that 3 is equal to 50. Let's look at an example, or let's start working with now equations which contain brackets. So we're asked to solve 5 times 3x minus 2 in brackets is equal to 7 times 2x minus 1 in brackets. We need to remove the brackets. So in doing that, we say 5 times 3x, they're both positive, is 15x. Plus 5 by minus 2 plus by minus, when we multiply integers, gives a negative sign because the signs are different. Like signs give plus, unlike signs give negative. So that gives us 5 plus 5 times minus 2 is minus 10. And 7 by 2x, both positive, 14x. And 7 times minus 1 is minus 7. Gather your x terms. So you have 15x minus 14x because you bring it over the bridge. It changes its sign. You have this minus 7 and this minus 10 becomes plus 10. 15x minus 14x is x. Minus 7 plus 10 gives us 3. Remember, when we're adding and subtracting integers, if the signs are different, we take the sign of the big number and we take the little from the big, which gives us 7 from 10 is 3. So x is equal to 3. So our second example here, 3 times 2x plus 1 equals 33. Remember, to remove these brackets, we need to multiply the outside term by every term inside. So 3 by 2x is 6x, 3 by 1 is 3. That's all equals 33. Look how I keep the equal signs all one directly beneath the other. Isolate your x. You've removed the brackets. There's no like terms to gather here. Well, actually, we have our x's here, and we're going to gather our like terms and isolate the x, which we have here, by moving the plus 3 over to here. So it's 33 minus 3, gathering those terms there. So that means 6x is equal to 30, which means that x is equal to this 30 divided by that 6, the coefficient of x. X is equal to 5. Okay, so final example of removing brackets. We will multiply 6 by 1 to give us 6, 6 by 2x is plus 12x, 5 by 3x is 15x, 5 by minus 1 is minus 5, and don't forget the minus 4 here, just add that on the end. Now, the x term on this side is 15, and that side is 12. Let's keep our terms on the bigger side. So we say 15x, bring over the plus 12 becomes minus 12x, and we'll bring over our minus 5 or minus 4 to become plus 5 plus 4 plus the 6 that we have anyway. Adding these up gives us 15 is equal to 15x minus 12x is 3x. So 3x, if 3x is equal to 15, this x must be equal to 15 divided by the coefficient of x, which is 3. X is equal to 5 in this example as well. So let's look at forming equations. Look at this one. I think of a number, x. I subtract 2 from it. I multiply the result by 3. There should be a 3 there. And the result is 9. That's how you form the equation of this story. I think of a number x, I take 2 from it, I multiply the result of all of that, whatever that is in there, by 3, and that's all equal to 9. Look at this second one. I think of a number x, I treble it, I write a 3, I subtract 7, and the result is 15. That's the equation of that story. We'll carry on looking at forming and solving equations in our Solving Equations Part 2 video.